Hey guys, Mr. Zaghetti here. Today we're looking at graphing logarithmic functions and their relationship to exponential functions. We're going to start here. I've got my table of values already filled out for a few basic things. I've plotted my points. So my basic function here is going to look something like that for y is equal to 3 to the x. I've got another one that is y equals to the 1/3 and to the x power. It's going to look more like this. Alrighty. And then now getting into the new topic for today, we already knew how to graph exponential functions. Now we're taking a look at logarithmic functions. There's this line here. And to go from an exponential function to graphing a logarithmic function, we're going to reflect our graph of y equals 3 to the x over this line. So I've already gone ahead and plotted the points. So our graph over here, once we found the inverse of our initial exponential function, y is equal to log base 3 of x. Those are my table of values. And when I plotted them, it looked something like this. All right. So now we've got two quick vocabulary words. It's important to understand the relationship between these graphs is our horizontal and our vertical asymptotes. For our exponential functions, they have a horizontal asymptote of y equals 0. They won't cross that line. Meanwhile, our logarithmic function has a vertical asymptote of x equals 0. It also won't cross the y-axis in this case. So it's important to remember that although it says x equals 0, it's actually represented by vertical lines that are parallel to the y-axis, and the horizontal asymptotes from our exponential functions will be horizontal parallel to the x-axis despite saying y equals 0. So this is important when we're calculating the domain and range or just finding them. So since the horizontal asymptote is preventing the range or the y values of our exponential functions from going below 0, it's safe to assume that the range must be y is greater than 0. So that would be our range, and our domain is all real numbers. So all the x values for these exponential functions would be able to result in a y value. So the domain of exponential functions is all real numbers. So it's pretty much the opposite when we've got the vertical asymptote. In this case, the domain is limited because you can't have a negative value within the argument of a logarithm. So it's not going to go past that y-axis there. So x is going to be greater than 0. So that's our domain for the logarithmic function. Meanwhile, y, or the range, is the all real numbers again. All right. So now we're going to go ahead and look at some translations, some growth, some shrinking, some compression for these graphs and seeing how that relates. All right, let's look at how this compares. We've got some transformations here. These graphs are now going to be translated 2 units to the left. So my first one here, my exponential function y equals 3x plus 2, is going to look something like this. Notice this time, instead of it being at 2, 9, it's actually going to be at 0, 9. It moved over 2 units. In the same way that this one also is going to start way over here at -4. So we had to move everything over 2 units in order to keep the y values the same. So far though, the horizontal asymptote has not changed. We didn't do any vertical shifts. All right. And then the last one, looking at our logarithmic function, again, we found the inverse of the initial exponential function, and it takes us all the way down here. All right, and we're going to look at one more translation. This time it'll be a vertical shift. All right, it continues to get more interesting here. So what we've got is our next one with our vertical translation is going to be moving down 2 units. So again, we're going to go ahead and start with our pink graph of y equals 3 to the x plus 2 minus 2. It'll give you something like this. So we took this graph that we had already gone ahead and moved left 2 units, and we went ahead and moved it down 2 units. All right. Now let's take a look at our next graph. Again, it's y equals 1/3 to the x plus 2 minus 2. So we took this graph and we moved it down 2 units. So it should look something like this. All right. And then our last one, we have our logarithmic graph. And again, we've done our similar transformations that we found from finding the inverse of our initial exponential function. And again, your graph is going to look something like this. So, as you can see, it is also steadily moved. Initially, the asymptote did not change, but now the asymptote here, the vertical asymptote, has been moved 2 units. All right, so we've got our last little part here. I went ahead and multiplied it by 2 and 1/2. Did the same with our logarithmic graph over here. When you find the inverse of that, this is what you end up with. So our first graph over here, you can see it grew a lot faster. Reflected over the line y equals x, and you have the same result over here. And then finally, when you do 1/2, it grows a lot slower.